We'll now start looking at different ways to determine whether a series converges or diverges. And we start with something known as the divergence test. The divergence test is one of the easiest ones to check, and it should always be your first stop. And what the divergence test says is it states that if a series converges, then the limit of that series is 0. So if the summation of a sub k converges, then the limit as k goes to infinity of a of k equals 0. However, this is not the form that we use it in the most. The form we use it in the most states that if the limit as k goes to infinity of a sub k is not equal to 0, then my series diverges. The idea is that eventually I'm going to get to a point, let's say this limit is something like 1. Then eventually I'm going to get to the point where I'm going to say 1 plus 1 plus 1 plus 1 infinitely long, and that's obviously not going to converge to anything. And that's true no matter what number it is. So the only way for this to converge is if the limit's 0. Just because the limit is 0, that does not mean the series converges. We can only tell if it diverges using this method. So let's look at some examples. Here I have this series 1 to infinity of 4k squared minus 6k plus 2 all over 7k squared plus 2x plus 1. For the divergence test, I need to take the limit as k goes to infinity of 4k squared minus 6x plus 2 all over 7x squared plus 2x plus 1. And since I have a k squared on both the top and the bottom, I can just look at coefficients and get 4 over 7, which is definitely not 0. So I'm able to definitively say that this series will diverge. For our next example, we want to look at the sum from 1 to infinity of -1 plus -1 to the k over k. So once again, we're going to take the limit as k goes to infinity of 1 plus -1k over k. And so this -1 to the k is going to kind of throw things off because this is going to be bouncing between -1 and +1. However, if I think about it, the limit as k goes to infinity of +1 over k is 0. And the limit as k goes to infinity of -1 over k is also 0. So the limit of that term is 0. So I have 1 plus 0, which is 1. And so this series also diverges. Now let's look at the series 1 over k, and this is known as the harmonic series. If I try to take the limit as k goes to infinity of 1 over k, I get 0. So my divergence test is actually inconclusive here. It does not tell me that this series converges, even though my limit is 0. In fact, we'll show in a later video that this actually diverges. So just because the limit's equal to 0 does not necessarily mean it converges.